All right, welcome back, everyone. Ready for another deep dive?
Always.
Today, we're stepping into a world where science fiction is blurring with reality. Directed energy weapons.
Yeah.
Specifically, we're looking at how these weapons are being developed to counter a threat that's becoming, well, let's say, more and more prominent drones.
Absolutely. It's a rapidly evolving field with some really interesting developments.
Right, and we've got two prime examples lined up to explore today.
Okay.
Our first stop takes us across the pond to the UK.
Okay.
And our source.
Oh.
A press release straight from the UK Ministry of Defense. They've been busy, let me tell you.
Yeah.
They've successfully tested a radio wave weapon, and get this, it can take down a drone for less than the price of a pack of mince pies.
Seriously?
Seriously.
Wow, 10 pence a shot. That's
Mind-blowing, right?
That's incredible, especially when you think about the implications. I mean, if
Yeah.
that figure holds up in real-world scenarios,
Yeah.
it could be a complete game changer. Smaller nations, even non-state actors, could potentially access this technology.
Right. It really challenges that whole idea that advanced weaponry is only for those with, well, bottomless pockets.
For sure.
So how does this British marvel actually work? Are we talking some sort of super-focused laser beam situation?
Not quite a laser, but you're on the right track. It's all about disrupting the target's electronics.
Okay.
This system uses high-frequency radio waves to essentially fry the drone's internal circuitry.
So like an electronic overload.
Exactly, causes it to malfunction and crash.
And they're saying it's effective up to a kilometer away, even when mounted on a vehicle. That's some serious tactical flexibility.
Oh, absolutely. Imagine a convoy moving through hostile territory with that kind of protection. It
Yeah.
could be a real game changer for ground operations.
Now, the press release also highlights the collaboration behind it. A consortium of British companies supporting over 135 jobs.
Right.
The minister in charge of procurement even called it a crucial advantage against emerging threats.
Interesting how they're framing this, emphasizing not just the military applications, but the economic benefits as well.
Yeah, it's definitely a multifaceted issue. Now, for our second source, we're hopping across the Atlantic to the US.
Okay.
A company called Epirus is making waves, so to speak, with their Leonidas system and their weapon of choice, high-power microwaves.
Ah, so a different approach from the UK's radio waves.
Exactly. And Leonidas is designed for a whole other level of, let's say, sophistication.
Okay, how so?
While the UK system seems more focused on individual targets, Leonidas can take down single drones in crowded spaces or even engage multiple targets across a wide area.
Wow.
It's like a high-tech fly swatter, but with a lot more power and precision.
Yeah, I can imagine.
The article we're looking at mentions it's already being integrated onto Stryker vehicles, those 8-wheeled armored transports used by the U.S. Army.
I've seen those, yeah.
And that's just one platform. They're also testing it in aerial deployments using something called the Leonidas pod.
Interesting. So we're talking about a layered defense system, potentially,
Potentially, yeah.
where directed energy weapons could be deployed from land, air, maybe even sea.
Exactly. And speaking of deployment, Epirus seems to be racking up some serious partnerships. They're working with Northrop Grumman, General Dynamics Land Systems, and they even have contracts with the U.S. Army for prototype development and delivery.
So this is definitely more than just a research project. There's real momentum behind this technology.
Absolutely. It's clear that directed energy weapons are rapidly moving from, the realm of experimental tech to a core component of future military capabilities.
Yeah, it's moving fast.
It really is. Okay, so we've got these two distinct systems, both using directed energy to counter drones.
Right.
But they're using different methods.
Right.
What are some of the key technological differences we should be aware of? I mean, radio waves versus microwaves, how does that impact what these systems can actually do?
Right. That's a great question, Adela. That's a great question. And it's a little like comparing a floodlight to a spotlight.
Okay, I can see where you're going with this.
Radio waves, like the ones in the UK system, they tend to spread out, cover a wider area.
Okay.
Microwaves, though, microwaves can be focused, much tighter beam.
So if we're thinking tactically, the UK system, maybe it's better for multiple drone targets over a larger area.
Yeah.
But Leonidas, with the microwaves, more precise, taking out a single target, even in a crowded environment, almost like a surgical strike.
That's a good way to put it. But there's another layer to this, We've got to consider the types of electronics each is best at disrupting. Some components, they might be more vulnerable to radio waves, others to microwaves.
So it's not just about the energy source itself.
Right.
It's also about how that energy interacts with the targets, I guess you could say, weak points?
Precisely. And that's where the development process gets really interesting. You've got this combination of scientific understanding and real-world testing.
Yeah.
Researchers are constantly learning how these weapons interact with different targets, leading to more targeted and sophisticated designs.
And speaking of sophistication, the Leonidas system, it really stands out. It's not just blasting drones with microwaves. It's a whole integrated system. AI, advanced targeting, even adapts to evolving threats.
Right. They call it smart power, I think.
Smart power, yeah.
And that AI integration, that's huge.
Yeah.
It's not just about shooting down drones. It's a system that can autonomously identify, track, engage threats.
Right.
And that brings up some serious questions about the future of warfare.
Right. Questions about automation, autonomy. We're talking about machines making life or death decisions. I mean, what are the implications of that? Where do we draw the line?
That's right. It's a real ethical and strategic challenge.
Right.
And there aren't easy answers. We're in uncharted territory, got to establish clear rules of engagement, international regulations to govern these systems.
Absolutely. Can't let the technology just run wild without thinking about the consequences.
Sure.
And it's not just misuse or intentional harm. What about those unintended consequences?
Yeah.
Can we use these systems without risking, harm to innocent bystanders? Civilian infrastructure, what if there's a malfunction, a miscalculation?
These are all valid concerns, really highlights the need for rigorous testing, robust safeguards, a deep understanding of the risks before we deploy these things widely.
There's like with any new powerful technology, there's this duality. Potential for great good and terrible harm.
The classic dilemma, isn't it? Fire, it can warm our homes or burn down a forest. It all boils down to how we use that power. And in this case, the stakes. They're incredibly high.
So where do we go from here? How do we make sure these directed energy weapons, with all their potential, all the risks, are developed and used responsibly?
The million-dollar question. I don't think anyone has a definitive answer yet, but awareness is key. We have to have these conversations. Not just military circles, but society as a whole. The more we understand about this technology, the better equipped we'll be to shape its future.
I completely agree. Knowledge is power. In this case, it could be the key to preventing a future we really don't want. Okay, we've covered a lot, from the technical nuts and bolts to the bigger implications of directed energy weapons. As we wrap up, any final thoughts for our listeners?
Yeah, it's been a good discussion, a real eye-opener in some ways. It's easy to get caught up in the sci-fi aspect of these weapons, but when you see how quickly things are progressing, it's a bit of a reality check.
Yeah, for sure. It underscores the need for these conversations. We can't just leave this to the engineers and the military strategists. This tech, it affects us all. We need to be part of shaping its future.
Absolutely. You mentioned international regulations, ethical frameworks. How do we even begin to approach that? I mean, given how fast technology develops these days and how easily it spreads.
It feels like we're always playing catch-up, right? Trying to create guidelines and rules after the technology is already out there.
Often the case, yeah. Highlights the need to be proactive, collaborative, bring everyone to the table. Governments, industry experts, ethicists, even civil society. We need a framework that anticipates the challenges, addresses them head on.
It's a tall order, for sure, but essential if we want to avoid some of the potential pitfalls. We've seen it before, haven't we? Powerful weapons destabilizing whole regions, leading to unintended consequences.
And with directed energy weapons, the potential for unintended outcomes is even greater. I mean, we're talking about systems that can knock out infrastructure, disrupt communications, even cause physical harm.
The stakes are high, no doubt about it. That's why these conversations about the ethics of it all are so crucial. We've got to move past the cool factor and really grapple with the downsides.
I agree 100%. Got to be clear-eyed about the risks, but acknowledge the potential benefits too. Maybe these weapons actually make the world safer, deter aggression, provide a more precise, less destructive means of defense.
That's the hope, isn't it?
But it all hinges on how we develop and deploy them.
It always comes back to human choices, doesn't it? The values we prioritize. Do we want a future where technology calls the shots? Or one where we use it responsibly to create a more peaceful world?
That's the question we all need to be asking. And the answer? Well, it's not going to be found in some lab or on a battlefield. It's a question for everyone.
I think that's a great point to end on. This deep dive has given us a lot to think about, both the technology itself and the implications, the ethical societal questions it raises.
Definitely food for thought. I hope it encourages our listeners to keep exploring this issue. It's complex, it's constantly evolving. But it's crucial we engage with it.
Couldn't agree more. As we've seen, the future's being shaped right now. We all have a role to play in making sure these weapons are used for good, not for ill. So, stay informed, stay engaged, and as always, stay curious. Until next time, thanks for joining us.